Hello, everybody. Welcome to Data Viz Live, our this week edition with Elijah Meeks, where we will be talking about time series charts. We're super excited to have everybody here. We're going to give everybody about a minute or so just to join, and then we'll get into the exciting content. While we wait for folks to join, we'll do a quick round of introductions for the folks on our side. Hi, everybody. I'm Michelle. I'm the Director of Marketing here at Notable, and I'm super excited to kick this series off with everybody. I will pass it over to Dave.
Yeah, hi everyone. I'm Dave. I'm Director of Product here at Notable, and we'll kick it over to Elijah next, who we're all here to see.
I love that Dave and Michelle give these very short introductions. My name is Elijah Meeks, and I'm required to give a long introduction. I'm the Chief Innovation Officer here at Notable, and also I have written a book about data visualization with D3 a couple of times, and done a series on it, a video series, and written a lot of blog posts, and done data visualization for, I guess, near a decade and a half. So that's my way of saying that I do data visualization. I think about it a lot, and we're excited to start, as Michelle said, this series where we just talk generally about different forms of data visualization, what you might think of as charts, and discuss how to use those effectively. We're going to be using our product, Notable, to show these different kinds of charts, like the time series charts we'll look at today. But you can use the tips that we're going to talk about in any kind of tool that you might use to develop data visualizations. So whether it's a BI tool or your own, or if you're using the popular libraries out there like D3 or Seaborn or something like that. Now, as Michelle said, we wanted to wait a little bit to let people get in, because we know that this is streaming on a couple of places. I'll key off of you, Michelle. You let me know to get started.
I think we're at 102, so let's get started, Elijah. Go ahead and dive in. Yeah.
Great. So when we think about line charts, we think about change over time and tracking change over time. And it's one of the most popular data visualizations, right? For some people, there are only three kinds of data visualizations. There's a scatter plot, a bar chart, and a line chart. But the important thing to think about when you're considering change over time and visualizing insights on that sort of temporal axis is that you really aren't dealing just with line charts. You shouldn't just think about line charts. You should think about what they refer to as series, right? Like you're seeing a series of data over time. And the reason why I say that is because a lot of the charts we look at are line charts. They use lines to show change over time. Here's a simple view of various weather stations here in Northern California and how much precipitation they recorded back in 2021, 2022, so during that rain year. And it was a drought year, so clearly it's very low. And these are done with lines, right? The mechanism we use to encode a data point at a certain point in time is this connected line. Now, I'm not going to spend too much time on this because if you're tuning into a video about data visualization, then you probably already know what a line chart is and how to deal with a line chart. So I'm not going to go too far into what line charts are. But I do want to point out that not all line charts even are just tracking the metric at that point in time. So we often use cumulative charts, especially for precipitation, especially for phenomena that build up over the course of time, where that buildup is one of the meaningful aspects of the data. So we have the same data here being shown at every point when those weather stations recorded precipitation in a monthly cadence. And then what we have is the same data done as a cumulative line chart. And a cumulative line chart allows me to see the buildup over time of rainfall at these different weather stations. You can see that one of these weather stations, Angwin Pacific Union College, initially had more rainfall, but then it was eventually surpassed over the course of the season by Potter Valley. And so that's what a cumulative chart allows you to see that you might not see if you were just tracking the individual data points over time. So as I was saying, there are line charts. We use line charts to look at temporal data, but then we use also area charts. And so these are two different kinds of area charts here. One of them a stacked area chart, similar to the line chart we saw above. A stacked area chart allows you to see the aggregate value at each point in time. So in this case, what we're seeing is the total amount of precipitation as measured by all of the different weather stations every month. And this allows you to see interesting things like the share of whatever phenomena you're tracking, organized by or ranked at every point. So you can see that again that Angwin Pacific data point is pretty high, and then it's much lower later on. So you can see that the majority of the rainfall during this particularly rainy part of the year, so the December rain, was in these two areas, the Potter Valley and that Angwin Pacific, and then over to the right, you can see that it sort of trickles out. No pun intended. But what happens with charts like these, when you're looking at these aggregated stacked area charts, you can get thrown off by the magnitude of change. So we have a huge amount of rainfall, as is typical in California rainy seasons. A huge amount of rainfall in the winter, especially in December. And then we have very small amounts of rainfall later on, especially in the summer months. But it might be critical to our readers to actually know what the breakdown is by percent, regardless of what the magnitude was. That happens in situations like this, with data like this all the time. When you're looking at data that has dramatically different magnitudes over the course of the data set, then what you want to do is you want to unify it somehow. And so that's why we use what's called a stacked percent chart. So over here, it doesn't really matter how much rain fell, even though, clearly by reading the chart, 700, 600, 700 times more rain fell in December than in August. We can still see very clearly the breakdown of the different, or the makeup of what weather stations reported the most amount of rain, regardless of how much rain fell during that particular point in time. And so that's why you would use a stacked percent chart like this, as opposed to a stacked area chart. So this is all the same data, just being shown in very different ways. Another tip is to provide your readers with the same data in different ways, because these charts all provide context for each other. So you might have a primary question. You might have someone come to you and say, look, I need to know how much rain fell at Potter Valley. And that question can mean very different things. So by providing them not just with plotting the raw data in a traditional time series line chart, but also providing with the cumulative and maybe the breakdown based on percent, then you're answering the possible permutations of that question. And that's always very important in providing your reader with the data in the way that they expect it. Because even when people are asking questions, those questions don't necessarily map to one chart or another. And even if you know explicitly, if they say, look, I need to know the cumulative amount of rainfall for that place, providing these other charts can give them good context to help them develop further questions. So we've got line charts, and there's lots of different ways. There are other ways of presenting time series data. There are line percent charts. There are bump charts and bump area charts. But what I want to get into now is talking about how we might decorate or modify a line chart based on the kind of data that you're presenting. So typically, when we look at a line chart, we see that sort of linear rendering. And that sounds like it's kind of redundant, a linear rendering of a line. But what I mean is that we are drawing a straight line from each data point to the next data point. And that's very typical for rendering a line chart. Sometimes you might also see a curved line. But keep in mind that there's another method that you might use called what's known as a stepped line. And what's called stepped because it has these very clear stepped patterns. So this is, again, that monthly data set. I'm only looking at a few of the weather stations just to make the chart a little bit more clean. And when we see the change, instead of it being drawn as a straight line from each data point, it takes a step from the last reported value to the current reported value. So this, again, is a cumulative line chart, so we're seeing it aggregate over time. Stepped line charts are important because representations of your data are important to your reader. And by that I mean you should create data visualizations that have some similarity to the data that's being represented. If your data is a continuous phenomenon, if it's something that is happening from day 1 to day 30 every month, then it might make sense to show a curved or a straight line. But if your data is reported data, if it's some kind of report, especially if it doesn't happen every month, it doesn't happen every time unit, then drawing those straight lines from one point to the other gives this impression that it's continuous, that it's a continuous phenomenon, or that it's a continuously reported phenomenon. And so it's good to use different rendering modes for your line when the data actually has different characteristics that correspond to those rendering modes. Now that's a very sort of technical information design aspect of this chart. Another that's more about readability and sort of accessibility is using what we call these line labels. Now you can have line charts that, and you will have, of course, line charts that have some kind of legend that explains what each color means. But you can also use quite effectively the line itself as the legend. You can take the line, and if you're working with modern BI tools, there are many BI tools that do this. And of course, if you're writing custom code, you can just write this custom. But it helps to label the line directly, either with the name of the data set that line, the series that line is representing, or in this case, the final value of that line, right? So we can see the exact value, even though we've got these axes, and so we can get a general sense of the value. It's helpful, and it's actually quite engrossing. It pulls people in to see a chart that's decorated like this. So I think that this is a good, just general tip to make your chart a little more eye-popping, to use line labeling. It has a more sort of modern feel to it, and I think there's value in it from an analytical perspective too. So we got back to lines. We got away from those areas and got back to lines. So I want to get back to areas. Another kind of time series visualization. That's really
Elijah,
important.
do you mind if I interrupt really quickly?
Oh, not at all. Of course, of course.
We have a question came in asking, would you ever use this when the y-axis is logarithmic?
Would I ever use the stepped visual rendering, or would I ever use a line chart with a logarithmic y-axis? Absolutely, you would use both of them with logarithmic scales. So a logarithmic scale, what we're looking at here, these are linear scales. Each line is spaced evenly away from the next point. A logarithmic scale would scale the same value from 1 to 10 as it would from 10 to 100, as it would from 100 to 1,000, as it would from 1,000 to 10,000. You use logarithmic scales because data makes visual sense. Some data phenomena makes more visual sense logarithmically. It has a recognizable pattern logarithmically that it doesn't have in a linear scale. And so the challenge that I think that the person asking the question is concerned with is that stepping seems like it's about or and this is me just trying to sort of guess at it, that stepped lines sort of accentuate that vertical change, whereas a straight drawn or curved line is by its very nature, and I couldn't, this is hard to talk about. This is one of those hand wavy things that I wish I had a whiteboard here, but a curved or a straight line is kind of the average movement between 2 points. So on a logarithmic scale, that average is a little less accentuated than that straight stepped line, which is probably going to look a little bit more jarring in a logarithmic scale. But this is one of those hand wavy data viz answers where it depends. But yeah, I think that you could use stepped lines just fine, stepped line rendering in a logarithmic scale just fine.
Great, thank you.
Of course. So let me get back to ranges because I'm sick of lines and I'm sick of these liney questions. I kid, of course. We love questions, and if you have questions, I'm happy to stop and engage with them. Bounded ranges are really important for time series visualization because lines imply specificity and accuracy. And much of our data is not specific or accurate. And so when you're working with data that has uncertainty, when you're working with data that has intraday or intramonthly or whatever your unit is variation, then you want to leverage bounded ranges. So for instance, this is a very common set of data that we see that has bounded ranges. This is temperature. It's daily temperature. And again, from some weather stations here in Northern California. This is every hour. Oh no, I'm sorry. My hourly data, I guess, is coming up. Temperature, of course, has these natural bounds. You have a minimum and maximum temperature every day. So you have the average temperature that you'll see on the news, and then it'll have a high and a low of whatever, and you'll see it on your apps and everything. And so it stands to reason that you would want to visualize that as well. So when using bounded ranges, you allow your readers to see that there's variability, whether that variability is based on accuracy or just natural variability of whatever process you're charting. So you see bounded ranges in stock data when they look at the open and close value of the stock. You see bounded ranges for temperature data. And you also see bounded ranges with precision, right? When we're looking at, when we're mapping out effects of experiments, and we map out the range within which we can say statistically this is significant, the effects of this experiment. Another fun thing that we're seeing here is I took this temperature data, and then I split it out to say, show me the temperature for days when it was raining, which is in red, and days when it was not raining, which was in blue, to explore a very simple hypothesis. Is it colder on days when it's raining? And this discontinuous representation of time series data is also very powerful. So we end up with single days sometimes, which is basically just a line with a dot at the center, wherever the average temperature was. And then we have these discontinuous regions in blue and in red. And charts like these can be powerful analytical tools, but they can also be very engrossing. Remember, wherever you're building your chart, you're still living in an attention economy, even if you're building analytical applications. And so what you can do to develop a little bit more excitement with your readers is going to be is going to draw them in more and lead them to develop more sophisticated questions about the data, which is going to improve your organization. It's going to improve the data literacy of your organization over time. It's going to lead to more interesting charts and, more importantly, more interesting and more sophisticated questions. So try to leverage things like bounded ranges, discontinuous line charts. Recognize that the more that you get away from a simple line chart, the more challenging it is for a reader because it's going to be less familiar. But leverage this functionality and these tools to do more, to present the more accurately how the data might not be as precise as you think it is, or as it typically is represented. So another thing to think about is using smoothing. This takes that the daily data up there and smooths it to a 7-day moving average. You'll notice now the discontinuous ranges that they overlap, and that's because, of course, if you're doing a 7-day moving average, you're going to have overlap between the two. And you can see how this chart might be useful for asking certain questions, but now it becomes even more challenging to read. And again, there's that trade-off when you're using more sophisticated techniques than just a simple line chart to ensure that you're keeping in mind the familiarity of the chart and the data visualization literacy of your audience. Last thing I want to touch on before we finish things up is the concept of a multi-axis line chart. This one I'll get interactive with real quick. So multi-axis line chart just means that I have two axes, right? In the case of our tool, the axes are colored by the line color. That might not always be the case, but I find that's a useful way to let people know which axis associates with which series. If I didn't have a multi-axis line chart with data like this data is very much out of scale, right? We're looking at pressure and we're looking at temperature. And pressure is measured in millibars, and millibars doesn't get much higher than 10 on the weather stations that we're looking at. Whereas temperature in the weather stations we're looking at is in the 50s. Now you might have data that's even more out of scale, right? You might be looking at the volume of trades during a day versus the closing price of a trade. In those cases, the traditional line chart isn't very useful because the magnitude of variation is blown out by the scale, by the shared scale of the two series. So instead you could use a multi-axis line chart, and I've seen these with more than two axes. Really, you shouldn't use them with more than two axes. In fact, there's one that's been floating around Twitter the last couple of weeks that's got 4 axes, and it's just a horror show of line with data. But by using a multi-axis approach, as we're doing here, we can now see the magnitude of variation sort of without that shared scale, without blowing out that shared scale. And so we can see changes in temperature, and we can associate changes in pressure, and we can ask ourselves, well, why is it that most of the time it seems like the pressure rises a bit in the same sort of pattern as change in temperature, but on a couple of days it seems like the pressure stayed very low, and a couple of days it seemed like the pressure was very high, and at one point in the middle of the night, the pressure really seemed to spike. And you can ask those questions more effectively than you might have if you had just seen this, as I was saying, without that multiple axis, right? All of those patterns have suddenly disappeared that I was just referring to. Finally, splitting out data, right? You can take data and what you want to provide, just like you want to provide tools for your readers to smooth data, you want to provide tools for your readers to split and aggregate time series data, because the best thing for time series data is context, and what's going to provide context better than anything else are the dimensional or categorical splits that exist within your data. So how can I tell that the pressure changes at this weather station are normal? Well, I would compare it to a weather station in a similar situation. So comparing, this is more about data analysis than it is about data visualization, but you do want to provide a data visualization side to it, which is trying to understand and provide context is going to happen, is key to creating good data visualization. And the best way to provide context is actually within the data set itself, if the data set provides these sort of subcategories or splits where you can show the average and then you can contrast it with the individual categories that are in the data. So I'm going to stop there, Michelle. I think that took us quite a ways through time series charts. I hope people found it valuable. I found it real enjoyable to talk about.
Elijah, actually, there's kind of one last question to kind of wrap things up here that came in. You touched about it briefly in that last section there, but if you had to talk about some of the common pitfalls or things to avoid when using this chart type, would you what recommendations would you have there?
Well, I think that one of the things that we have to be careful with time series charts is that they are so exact. They look so exact. You draw a line from one point to another, and somebody just assumes that angle of that line is exactly how whatever you're talking about changed at that rate from one point to another. So that's why you really do want to get more comfortable using things like different ways of visualizing it, like using stepped interpolation or stepped line rendering. But also get comfortable with discontinuous lines. I've seen so many, especially in engineering context, I've seen so many line charts where the back-end reporting was every hour, and then 36 hours later, there was a report. And there's this giant line drawn like across this weird chart. And instead, they just should have been comfortable putting a gap there. Like, be comfortable showing gaps, be comfortable showing that the precision isn't, that things aren't exact, and learn to leverage, depending on what your tool is. Not all tools have access to different ways of rendering line charts, but when you can, try to think about the kind of data you're representing and what kind of sort of visual form makes the most sense for that kind of data.
That makes sense. Thanks, Elijah. And on that note, I think we will wrap up the live stream. So thank you everyone for joining us, and we will see you next week for Data Viz Friday Live. Take care, everybody.
Thanks, everyone.